Okay, now we begin our discussion of rational functions. And we're moving on from polynomials to another type of function. And we're going to analyze the graphs of those functions and many things about them. So you spent two sections on rational functions, both 5.4 and 5.5. So this is the introduction to them. So first of all, the basic rational function, the parent function, is 1 over x. F of x equals 1 over x. And so if you think about graphing 1 over x, I think we looked at that way back at the beginning of the class, right? If you put in numbers for x, you'll be able to see where the graph goes. So if you put in 1 for x, you get 1 over 1, 1. But if you put in 2 for x, right, x is 2, you'll see that y is then 1 over 2, or 1/2, so it's going right here. And then if you put in 3, you get 1/3, etc. If you put in 100 for x, you'll get 1/100th. So it won't go negative, but it will get closer and closer to 0 here. Okay. If we put in for x, if we put in, let's say, 1/2, okay, for x, so it would be right here, well, it would be 1 divided by 1/2, or in other words, 1 times 2. So 1/2 comma 2 is on the graph. And likewise, if you put in 1/3, you get 3, and etc. We're getting closer and closer to x is equal to 0 there. So that's this portion of the graph. And then if we start putting in negative numbers for x, we quickly see a pattern. So if we put in -1, we get -1. If we put in -2, over here, we get -1/2. And so what we actually end up with is an odd function that reflects across the origin, right? So this is symmetric about the origin. And we know that that makes it an odd function, okay? Another very common rational function that you will see is 1 over x squared. I wouldn't so much call this a parent function, but I think it is nice to kind of look at it and see what it looks like. So if we put in 1, we get 1 over 1. So we're still right here. If we put in 2, we get 1/4, right? So it's a little closer to that x-axis. If we put in 3, we get 1/9. So it's really doing the same thing as the first graph, but what it's doing is doing it a little quicker, right? So it doesn't look too much different. It just does get closer to 0 faster. However, on the other side, if you put in -1 for x, you actually get +1 for y, right? Because when you square the negative. So the other half of the graph looks like this. Okay, and so it does still have these two pieces of the graph, but this graph is symmetric about the y-axis, and so it is an even function. Okay. Now, a couple things about these graphs that we need to notice. We talked about how this was getting closer and closer to 0, but not crossing it. That is called a horizontal asymptote. Okay, so note the spelling of asymptote. It's a pretty funny word there, but a horizontal asymptote is a horizontal line that the graph gets closer and closer to, but does not cross. Okay, so we can see that the horizontal asymptote on this graph is y equals 0. It's that horizontal line the graph gets closer and closer to, but does not cross. We also have what's called a vertical asymptote. So in the same manner, the graph is approaching that vertical asymptote, just getting closer and closer to it, but not crossing. So this is called a vertical asymptote. And this vertical asymptote on the parent function is at x is equal to 0. We have the same two asymptotes on this graph. So notice that we have the vertical asymptote of x equals 0, and we have the horizontal asymptote. This time it's just getting closer and closer to 0, but from above both times. And that is also of y equals 0. Okay, so the first step in understanding these rational functions is to look at their graphs and graph them using transformations, okay? Because we're learning rational functions now, and we also have already learned about transformations, so it's good to start with something that we know. So graphing using transformations. So for example, if we had f of x is equal to 1 over x minus 2, okay? So what we would say was, hey, there's a transformation. Look, it's happening in the x portion of the graph. So this is a shift. And remember, in the x's, it kind of does the opposite. We need to add to. So we're doing shift right 2. Okay, so for every x coordinate that we have, we're going to do x plus 2. So to graph, we can make a table. Remember when we did transformations, especially big ones, we used a table to graph them. For this, I think since it's just a shift to the right 2, it's probably easy enough to say, well, we're going to shift it to the right 2. That's here, here. So now our vertical asymptote is going to be here at x equals 2, okay? Our horizontal asymptote remains. Nothing happened in the vertical direction, didn't shift up or down, so that remains at 0. And then our graph looks like this. We can plot actual points on the graph just by plugging numbers in for x, or by taking our original graph and then adding 2 to all the x's, okay? So in other words, in case you need some specifics there, right? This point on the graph was 1, 1, so now this point is 3, 1, right? Another point, since there's fractions involved, remember the point was 2, 1/2, but now the point would be 2 plus 2, 4, 1/2. Okay, so, we're changing those x values. All right, let's look at another one. Let's look at f of x is equal to 1 over x plus 3 plus 2. So we have two transformations here. Notice that they are both shifts. We're not going to do a lot of more complicated transformations on these. So first, notice that in the x's, we have a shift. Since it's plus 3, that would be to the left 3. And then this plus 2 is happening to the entire function. So this is a shift up 2. Okay, so this shift left 3 means x minus 3, and the shift up 2 means y's plus 2. Okay? So when we try to graph this, Again, we're starting with that original one, and we're shifting left 3, so our vertical asymptote, instead of being at 0, x equals 0, it is now at x is equal to -3. And our horizontal asymptote, which was at 0, y equals 0, is now at y plus 2 right here. So this is our horizontal asymptote of y equals 2. Okay, and then we're going to graph our function just approaching those asymptotes. If you're graphing in MyMathLab, you do need to probably add some specific points in, right? But that's just kind of what the graph would look like if you're doing this by hand. So in other words, this point that was 1, 1 is now 1 minus 3, so -2, and then 1 plus 2, so 3, so -2, 3. So each time you have a point, you're just subtracting 3 from the x's and adding 2 to the y's. Let's look at one more. Okay, f of x is equal to 1 over parentheses x plus 2 squared minus 3. Okay, so I want to show you this one because it is the squared version of the graph. So we still just have really 2 transformations, and the one is that plus 2 in the horizontal direction, so that would be a shift, let's see, to the left 2. And then the -3 is a shift in the vertical direction, down 3. So in the x direction, that's x minus 2, and in the y's, it's y minus 3. So when we graph this, remember that we're actually graphing the second version of the graph, the 1 over x squared graph. So if we shift left 2, that moves our vertical asymptote. And if we shift down 3, that moves our horizontal asymptote. So we want to note down that this vertical asymptote is now at x equals -2, and our horizontal asymptote is at y equals -3. Okay, and then we're going to draw this graph here and up here. Okay.